This is an orthokeratology case where we have a little bit of induced cylinder in one eye and undercorrected cylinder in the other. And there's also mild decentration of the treatment zones. They're not too bad, but we can probably address that a little bit with since we're changing lenses. Anyway, I think we can go a little bit bigger, measuring at about 11.4 to 11.5. So I think we're with an 11.0 lens right now, and we can go to an 11.2. So 11.2, and I'm gonna change these back to 6.2 and 6.8 where you had them. We also need to reset our center thickness. So if you look at the periphery of the posterior topography, it's pretty blue all the way around, mid-30s here and mid-20s here. So pretty good alignment, maybe a little bit too tight even. So I think we should loosen the periphery all around and then loosen a little bit more in the horizontal meridian. So at 2013, I'm going to give ourselves about 7 microns worth of change. And then I'm going to, in 50% mode now, bring this up another 7 microns. Let's go one more. So now in the horizontal, we're about 15 millimeters, a little bit less depth, and 7, not millimeters, but microns less depth, and then vertical about half that amount. So that should loosen up the lens a little bit. And sometimes when it's drawn too tight in the periphery, will induce some weird optics here at the treatment zone. Then with the larger diameter, I'll hopefully get this side looking a little bit better. Power-wise, the patient was overcorrected by about a half diopter, but has some residual cylinder, and so it's pretty close to plano EDS. I think we're okay leaving that alone. In the left eye, we have the lens with a oval zone, and that's because we can see the 2 diopters of corneal astigmatism was fully manifest in the patient's prescription. In the right eye, in comparison, the patient's got quite a bit of internal astigmatism, which canceled out a lot of the corneal fill. So I can see why you went with an oval zone on this side, and I would probably do the same. I think we can also make this side a little bit bigger. We'll go to an 11.2. And let's bring this down to the 6.2 and 6.8. We have power of 1.1. We're a little bit overcorrected in this eye. And I'm going to pause the video and take a look at the case. The posterior refraction on this side was plus 1.25, minus 175. So I think we can reduce the demand here. Well, let's fix the center thickness first. And cut about 3/4 out. So we'll be close to about a 50. And speed this up a little bit. And right now our differential is a little bit more than a diopter. I think we're going to have to bump that. I'd go for about 250 differential, so we'll want a 3 here. I'm also going to change the zone here. In the horizontal meridian, our placements were at 6.2 and 6.8. So in the vertical, I'd recommend going with about 5.6 and a 6.2. By doing that, we get and I just goofed because I'm in 100% mode still to make sure I didn't move this one. 6.2, 50% will be 5.6. This way we have the intermediate control point line up with the OZ control point, which I found works pretty well. Make sure we have this correct. And then here we're at about 250, so we want a little bit more. Differential of 250 means our power will be at about 3. Can probably back off a little bit. And this one we'll have to bring up a little bit. It's going around, and I think we can make this a little bit more symmetrical. Okay, looking here in the periphery, high 20s. We might be able to loosen it up a little bit. I don't think that's critical. I think mainly for this side, we want to make sure we get the residual cylinder out of the way. So this lens, a little bit larger. We have a little bit more disparity in terms of power between the vertical and horizontal meridians, and that should take care of more of the patient's residual cylinder. So hopefully this video helps. Best of luck with your patient, and thanks for watching.